This is Chapter 4, Lesson 8, Quadratic Functions. So, in the previous lesson, you learned about nonlinear functions. Okay, so those are basically functions that don't form a line. A special type of nonlinear function is a quadratic function. Okay. A blank blank is a function in which the greatest power of the variable is 2. So in those two blanks, you're going to write quadratic function. So a quadratic function is a function in which the greatest power of the variable is 2. Its graph is U-shaped, opening upward or downward. So if it's a positive quadratic function, it opens upward in a positive U shape. And if it is a negative quadratic function, so the slope is negative, it goes down. All right? Quadratic functions. A quadratic function can be written in the form y equals ax squared plus bx plus c, where a cannot equal 0. The graph of a quadratic function is called a parabola. Okay, so that's an important word that you should know. So it's a U-shape. Parabola is just like a U-shaped function. So it's called a parabola. The graph opens upward if the coefficient of the variable that is squared is positive, and downward if it is negative. Okay, so what they're talking about here, so let's look at the first example. So this is going to be, you have the x squared, right? That means that's going to be a quadratic function. This 2 means it's a quadratic function, okay? Now, if you look at the x value, the coefficient in front of x is 1, positive 1, which means I'm going to have an upward function, okay? So, number 1 says graph y equals x squared. To graph a quadratic function, make a table of values. Plot the ordered pairs and connect the points with a smooth curve, okay? So I made a table of values, -2, -1, 0, 1, 2. This is very common as when you're just doing a regular quadratic function, just to pick these 5 numbers. You can pick any numbers that you would like, but these are the typical ones that you'll see. Okay, so if I plug in -2, -2 squared equals 4, so y equals 4, so my point is -2, 4. -1 squared equals 1, so -1, 1. 0 squared is 0, so 0, 0. 1 squared equals 1, so 1, 1. 2 squared equals 4, so 2, 4. Okay? Then I can go over to my graph and I can actually graph these points. So -2, 4 is right there. -1, 1, 0, 0, 1, 1, 2, 4. Okay? You can see that these points are all connected on a smooth upward curve. Okay? Number 2 says graph y equals -x squared plus 4. Again, I picked the same numbers, -2, -1, 0, 1, and 2, and I plugged them in. -2 squared is -2 squared is 4. -4 plus 4 equals 0. -1 squared is 1, and I have that negative out in front, so -1. So -1 plus 4 equals 3. 0 squared plus 4 is 4. 1 squared is 1. -1 plus 4 is 3. 2 squared is 4. -4 plus 4 is 0. Okay, notice there's a negative out in front, so that means my parabola is going to go downward. Okay, so if I look at my graph, I can plot my points. -2, 0 is right there. -1, 3. 0, 4. 1, 3. 2, 0. Okay, and again, this downward parabola because my coefficient was negative. Then I have example number 3. So example number 3 is a word problem. says the function d equals 4t squared. So there's my function. That's a quadratic function because it has that squared factor. Represents the distance d in feet that a race car will travel over t seconds with a constant acceleration of 8 feet per second. Graph the function, then use the graph to find how much time it will take for the race car to travel 200 feet. Okay, so time cannot be negative, so it doesn't make sense for us to actually graph the second half of the parabola, the negative half of the parabola, since time can't be negative, so only the positive, so use only positive values of t. Okay, and they did. They picked 6 values plus 0, so 7 total values, okay, to graph this. So when I do that, 0 squared is 0 times 4 is 0. 1 squared is 1 times 4 is 4, so 1 comma 4. 2 squared is 4, 4 times 4 is 16. 3 squared is 9, 9 times 4 is 36. 4 squared is 16 times 4 is 64. 5 squared is 100. Sorry, 5 squared is 25 times 4 gives me 100. 6 squared is 36 times 4 gives me 144. So here's my points. I'm going to go ahead and graph them on the line. You can see that they're graphed. 0, 0, 1, 4, 2, 16, 3, 36, 4, 64, 5, 100, 6, 144, and so on. Okay, so I can locate. Now the second part says use the graph to find how much time it will take to travel 200 feet, right? So I'm looking for 200 feet. So I'm going to look at my graph. It's at a distance of 200 feet. So I'm going to look for where 200 feet is on my graph. There's 200 right there. I'm going to go across. And that's my point. Then I'm going to go down and see where that matches up. Okay. So when I do that, okay, I've drawn that line, I get 7. So that means the car will travel 200 feet after about 7 seconds. Okay. You can always double check. You can plug in 7 into t. 7 squared is 49. And then multiply that times 4. Does give me 196, which is pretty close to 200. Okay. Number 4 says the function h equals 0.66 d squared. Again, quadratic function because of that squared. Represents the distance d in miles you can use from a height h feet. Graph this function, then use the graph to estimate how far you could see from a hot air balloon 1,000 feet in the air. Okay, so 2 things they're asking me to do. They're asking me to graph first, and then they're asking me to find something specific. So just like time, distance cannot be negative, so we're going to use only positive values of d. Okay, so picked a couple positive values. So I've got 0, 10, 20, 25, 30, 35, and 40. Again, you can pick any numbers that you would like. 0 squared is 0 times 0.66 equals 0. 10 squared is 100 times 0.66 gives me 66. 20 squared is 400 times 0.66 gives me 264. 25 squared is 625 times 0.66 gives me 412.5. 30 squared is 900. 900 times 0.66 is 594. 35 squared is 1,225 times 0.66 gives me 808.5. 40 squared is 1,600 times 0.66 gives me 1,056. Okay, so there's my points. I went ahead and graphed them on the line. You can see. They're all graphed, okay? The second part says 1,000 feet. So I go up to 1,000 feet, which is right there. I go across, and then I go down. So this tells me about 40. So, and it's a little bit less than 40 because we know 40 is 1,056. So that means it's a little bit less than 40. So at a height of 1,000 feet, you could see approximately 39 miles. Okay. So on the next page are the try it out problems. Go ahead, pause the video, try them out, and when you are done, we will go over the answers together. All right, now that you've had a chance to go over the answers, to check your answers, let's go over the answers together. So letter A says graph y equals 6x squared. So I'm going to come over here and I'm going to make a chart. Okay. My x and my y values, I'm going to pick 5 values, -2, -1, 0, 1, and 2. Again, you can pick whichever values you want. I just happen to pick those because they're the easiest ones for me to do. So then I have -2 squared is 4. 4 times 6 is 24. Okay. -1 squared is 1. 1 times 6 is 6. 0 squared is 0 times 6 is 0. 1 squared is 1 times 6 is 6. 2 squared is 4 times 6 gives me 24. Okay, then I can go ahead and graph this. So my first point was -2, 24. Okay, so it's up to -3. Okay. This parabola will open upward because it is a positive coefficient. Okay. 12, 16, 20, 24. Okay, so there will be 24. So -2, 24 is right there. Here's 1, 6, 0, 0, 1, 6, 2, 24. Okay, and then I'm going to connect my lines. Okay. So that's y equals 6x squared. Okay. Letter B says the outdoor observation deck of the Space Needle in Seattle, Washington is 520 feet above ground level. Use the graph to estimate how far you could see from the observation deck. Okay, so 520 feet above ground is what they gave me. So I'm going to go height, find 525, which is about, here's 500. So 525 is probably right around here. Okay, so there's my point on the graph. It comes down there. It's between 20 and 30. Here's 25. So it's between 20 and 30. Here's 25. So I'd say probably around 28 miles, you could see. Okay. You may have 27, 29, somewhere in there, but somewhere between 25 and 30, okay? All right, letter C says graph y equals -5x squared. Okay, again, I'm going to make a table. X and Y. Okay, I'm going to pick 5 points. Okay. So now I have -5x squared. Okay, so negative tells me it's going to open downward. All right, so now I have -2 squared is 4. 4 times negative 5 is negative 20. Negative 1 squared is 1 times negative 5 is negative 5. 0 squared is 0 times negative 5 is 0. 1 squared is 1 times negative 5 is negative 5. 2 squared is 4 times negative 5 gives me negative 20. Okay, so I'm come over here, make my graph. Okay, I don't have enough space for negative 20, so I'm going to go with negative 1. Negative 1, 5 is about right there. I have 0, 0, 5 like that. Okay. So again, parabola, nice and smooth. It's going downward because the coefficient is negative. All right. Now you will need a blue piece of paper that says quadratic functions on it, a pair of scissors, and a glue stick. Okay. It's really, really faint, but you see this dotted line right here? You're going to cut it in half, right along the dotted line. You have to, just in case something happens, you mess up, whatever the case may be. Okay, so I have 2, right? Okay, so you're going to take this one. You see these little tiny dotted lines as well? You're going to cut along all those dotted lines. Okay, only cut up to where the dotted line stops. Okay. So once you've done that, once you've cut all these little things, right, you're going to fold them in. Okay. So each one of these gets folded. Just like that, okay? Then on page 103, which is the blank page right next to the try it, you're going to glue it onto that page. You can glue it this way, you can glue it this way, whichever way you'd like to glue it. You're gonna flip it over and glue it. Page 103. Remember, you don't need a ton of glue. All right. So this is a foldable for quadratic functions, okay? So on the side where it says quadratic functions, you're actually going to be able to graph a function. The equation that you're going to use to graph your function is y equals negative 2x squared plus 3. So your equation is negative 2x squared plus 3. Okay, so there's a couple of things that we can already do. This negative out in front, okay, direction of opening tells me it's going to go down or downward, okay? We're going to talk about a lot of the other things in a second, okay? So I want you to go ahead, graph this function. So pause the video, graph the function. When you're done, we will come back and we will talk about some of the other things. All right, so now that you've had a chance to graph the function on your own, let's take a look at what you've got. So these are the 5 points that I've chosen to use, -2, -1, 0, 1, and 2, and I've gone ahead and I've worked out the math. So I get the following points: -2, -5, -1, 1, 0, 3, 1, 1, and 2, -5. So I can come down here and I can graph those points. There's -2, -5, -1, 1, 0, 3, 1, 1. And then 2, -5. Oops, sorry, this should be here. Those should be there. Okay. So when I graph this, I go up, just like that. Okay. So I've got my graph now. My vertex, which is where the top of the graph is. So if I look at my graph, my vertex is right there. So the point of my vertex is 0, 3. Don't worry about the width. Okay. Axis of symmetry. Okay, so it's the same on both sides. So the axis of symmetry is going to be the y-axis. Okay. And that happens when y equals 0. Okay. So the vertex is 0, 3. The axis of symmetry is when y equals 0. Okay, so now we can start looking at some of these tabs. The first one says domain. Okay. So the domain is the function's set of x values. So that's all the x values. So if I go and I look at my graph, right, my x values will continue to get bigger. The further I go down, the bigger they get, right? So my domain is going to be -infinity to +infinity, okay? So no matter what, my x values are going to get bigger every single time, okay? My range is the function's set of y values, okay? So on a parabola, there's always going to be a stopping point. My stopping point is 3, right? Because I have 3 here, okay? I can't go any higher than that. It doesn't make sense, but it will keep going down. So my y values are going to be -infinity up until 3. The rest of these tabs I'm not going to worry about right now, okay? So they're for a little bit higher level, all right? So these are quadratic functions. You need to know about the domain and the range, okay, and be able to graph them, all right? And that is the end of lesson 8.